Thank you all for the introduction. So, welcome everybody. It's still good morning. So I hope you all had a very good day yesterday at the conference. Now I want to talk about the project I did, and it's all about well, empowering and helping developers. First, a small introduction. The project I'm going to talk about, and I did and build it together with my brother, Ricardo and Cate, and together we created an open source framework, and we also gave it away at OWASP, so everybody can use it. This is not a talk where we're gonna bash developers. This is a talk where we really gonna appreciate developers, so it's really cool that Martin was before me, so you're already a bit warmed up maybe. So who of you all in this group are a developer? Cool stuff. Because, you know, how I see developers, it's more like Neo from the Matrix, right? The guy that has this unique skills, the potential to change the world, to really create a bridge between the business and, well, what you need to build, the source code. And, you know, developers are really doing awesome things. Just like Martin explained, you know, like most of the hackers can't really code big applications themselves. But you guys are doing this. It's very hard. So in my opinion, in my eyes, you guys are Neo, the one. And if we see the hackers, in this case, the agents, you know, they're everywhere. It's on an automated base. It's 24/7. It goes on. And you guys have to protect the business, the company from those evil, people. And I do see that you guys, as the developer, who have all the context, are the most important solution and whole problem we have and the gap in the security industry. So why did we create the whole framework? So we saw a lot of coding mistakes, a lot of deja vus, because I'm doing security penetration testing, code auditing, that kind of stuff for more than 10 years now. And it's still always the same story, the same things, almost the same reports I deliver. Sometimes it's very insecure, sometimes minor things, but still it's always the same thing. And it really bugged me that there is, after 10 years, no real improvement. And it keeps on going, you know, being harder and complexer. You have the whole, maybe, development pipeline, where you also have possible weak spots for an attacker. So we really wanted to help and share the knowledge we, experienced over the last 10 years, and share this for free for everybody. From the developers that are at the addict, you know, coding a cool application, or from the big companies that also need the awareness and the security information. So we wanted to really share this information. Because like I said, it's the current situation. You guys, as developers, you know, you are dodging bullets. And sometimes you still get hit, but this is the current situation. And I really would love to see this change. And as you all know, because you have seen the Matrix, of course, Neo has the huge potential to change the reality and to be the savior. And I think you guys, as developers, are the savior. You can really make the difference. Luckily, there are always options to take. OWASP has a lot of free information, knowledge, like the ZAP tooling, the secure programming guidelines, that kind of stuff. So there is information out there, but you need to know where to get it and where it is. Like I said, we really should improve our information, our knowledge about security, but it's still hard to find good spots where this information is like an authority you can trust on. Because, like, for example, when I did a Crosssite request forgery example, I looked on all the forums, Stack Overflow, that type of stuff, and from, like, I don't know, like, the 20 examples I found, like only 3 were really correct, like secure, enough entropy, really build a good way, or really creating in a good way a cross-site request forgery token. But all the other code examples were really insecure. So if you would pick one of the wrong forums, one of the other 18, and you would say like, oh, this looks pretty good, I use this concept, this idea, and you implement it, then later on you get, yeah, the security guy saying, hey, you're dumb, bashing you or whatever. So we want to create a place where everything is located on one spot, where there's transparency, where people can step in and modify. So basically, that spot is OWASP. I hope all of you know what it is, the worldwide non-profitable organization. And it's all about making the risk aware so you can take the correct decisions on which way to go. And I also want to say, for you guys, it's also important what you're going to do. Because you as a developer, you also should enforce and talk to your manager and say, hey, you want me to build this functionality, but it has to be built in a secure way. So you have to, really embrace one or the two. So you're going to take the blue pill, ignore everything, go back to Wonderland, and nothing happens. Or you take the red pill and, you get the reality, the painful reality maybe, but if you don't do it now, this gap will only increase in time. On the moment that there is no possibility to slap on security anymore in the end phase. So then you have a legacy product and hard. So it also starts with you guys as developers to really take responsibility and say, no, I'm not going to create an insecure application. I mean, a lot of people's lives maybe depend on the lines of code you write. So there were vulnerabilities where people died, right? We all know the stories, all seen them. And take your responsibility in this part. Also important, you really want to verify your code. Basically, OWASP, has also another really great project that's been out there since like 6 years. It's the ASVS. It's the Application Security Verification Standard. It's set up years ago by Andrew Stock, the project leader of this project, and it basically helps you as a developer to first use it as security requirements at first when you start a project, and later on use it to verify that you all did and implement all the security controls that are enlisted here. So you can also see you have different levels. So if you didn't do anything in your development team with security yet, then I would say go for level 1, increase, level 2, and based on how critical this application is, you can choose from a level 2 standard or level 3. Basically what I do, I would always use the level 3 because the company I work for is banking, trading companies, energy, so we always use the level 3. There are like 170 security controls in them, and that we also included in our Security Knowledge Framework project. So that's the next thing. The Security Knowledge Framework, like I said a little bit in the beginning, it's all about teaching and showing you the possible ways to approach certain type of functionality and really create it securely by design. So it's better to do things structurally already, in the beginning than trying to slap it on later. So you should do security by design. It's also about the security awareness. So we have different core functionalities in the framework, basically like 3, where you have the knowledge base items. There are more than 200 knowledge base items. So basically a knowledge base item says, hey, there is an attack vector that is this, and this. We don't explain in detail because you are not interested in that. You want to develop, you want to build the functionality in a secure way, but only to teach you that when you don't do anything about it, there is an attack vector possible. And then we also have a solution where we say, okay, this is the way you should approach this and think about all, the possible things that can go wrong when creating a certain type of functionality. So it's creating the awareness, and you as a developer can search in this knowledge base and get the information at the spot on the moment you need it. Also, we have the post and the pre-development phase and the post-development phase. The pre-development phase is more like a threat analysis, risk analysis functionality, where you can say, in this new sprint, I'm going to build these type of functionality or using these type of technologies to realize this functionality. And then the security knowledge framework can correlate those type of functions or technologies to knowledge base items. So even before you really start programming, you get already the awareness and the information you need to know before you start programming. So you can do it securely by design and not later on when the awesome hacker comes by. All the information of the security knowledge framework, so the code examples, the knowledge base items, it's all located on the GitHub. So it's everybody can see, fork, modify, add. And the whole idea is to really help developers, like Neo, when he got his skill and he unlocked his potential, right? That he can see, he knows where the agents are, he knows what they are doing, where they're at, and he can beat them. And basically, that is what I'm really hoping that you guys and girls can do, is get this information, use it, and really don't be in the situation that you have to dodge bullets. Because you're Neo, you can freaking stop them, right? You bend reality. That is what you guys can do. So I wanted to show the demo application of the security knowledge framework. So we have online, we have a demo that's being published every hour to the online demo site, because we also have a full continuous integration cycle. It's all about quality gates, and that's just what Martin also told. Security is part of quality. So, and also other tooling can help you as a developer with it. I'm going to log in, but probably I'll be kicked out pretty soon, because every like 12 o'clock it will refresh, so it will kick me out, but I will go through it. So the security knowledge framework is a Python Flask application that you as a developer can easily run on your own laptop. There are also instructions how to set it up in a web service like Apache or Amazon or whatever you want to use it there for business or inside a company. So, like I said, the most important thing, the core, is the knowledge base items. So in here you have all type of known keywords that you probably seen in a pen test report or a security report, and basically it will give you the awareness that you want to have before writing something. So for example, here we have the external entity injection. Again, it gives the description on what an attacker is able to do. And well, for this example, it's really easy, because you just have to disable the parser flag in the XML method saying, no, don't parse external XML entities. So as you can see, you can easily search things up, get information right on the spot. And as you can see, it's a pretty extensive list of all knowledge base items. So that is the first major important thing. But then we realize, well, you can talk about, well, you should take this approach, but it still leaves very much possibilities open to still implement it wrong, right? I mean, I can give you a generic message saying, hey, you should do it like this, but still we wanted to provide more and also guidance on the implementation level. So we also have full PHP and .NET code examples where we go through all the major security vulnerabilities and show with the code examples how to properly deal with it. So for example, the HTML. So the thing is, you are all pretty much developers here, right? Who knows what a Crosssite scripting is? So now I want to see, boom! Yeah, no? Like, not everybody? That's not much. Okay, so Crosssite scripting. Some people know it. And then my next question, who can tell me how to properly mitigate Crosssite scripting? So how do you deal as a developer with this issue, Crosssite scripting? So maybe first a security guy and then a dev guy, or? Okay, I like that already. Exactly. It really depends on the context. And a lot of people don't realize this. So they use the same escaping function in all the parts, in all the different contexts where there is user input. And as you know, that's not how you deal with it. So in this example, we have the specific HTML encoding function for the full cross-site scripting. So for example, if you have this, you inject it, it cannot be injected. It's good. Then we have the HTML attribute. So for this specific context of where user input is going to land, you have to treat it differently. In this case, you use the HTML attribute encoding. Same for the JavaScript encoding. And then we have a very nice edge case where if you have user input in a href, where you can specify the URL, then you can input JavaScript double point or data double point and do a base 46 string. And so then you're not needing any special characters, but you still can pop a cross-site scripting. So it's very important to realize this. And what we try to do is, well, document all this knowledge and into this framework with a lot of commenting with it. So you really have a guidance. And, well, we really want to try to explain the thoughts under the approach. We have code examples for .NET, PHP. We're now building Java code examples and building Python. As you can see, my continuous integration delivery pipeline is now refreshed because it's past 12. So I have to log in again. And basically, the code examples give you more guidance on the implementation level. So the knowledge base and the code examples, you can get them information on the go. We also have the pre-development phase and the post-development phase. So in here, you can say in the Security Knowledge Framework, I want to create a project. In this project, we're going to do the first sprint. So this is the pre-development phase, sprint 1. We're planning. We're like, OK, what type of functionality do we need? So we say this is sprint 1. And we want functionality like user registration. And we're going to do something with HTML, like displaying the logged in user. So here we can now say add different type of functions. And we can say, well, this is like a fully thing that comes popping up quite a lot, like dealing with user registration. How do you do that? Well, we have forms. We're going to use sessions, and we have, I don't know, we're going to do something with, good one. Let me see. User input, yes. So now I can say add those values. And what will happen now when I click on done, it will correlate all those, designs or technologies or functionality. It will correlate them to the knowledge base items. So in here, when you're going to do sessions, it's not only one thing you need to consider, but it's more like a whole pattern. Because if you miss one of those security controls, then an attacker can bypass your whole authorization layer or your session management layer. So it's really important to really go in depth and deal with all the things. Same for forms. When you have forms, you should always have a single input validation point in your application where you put all the user input through. You have to set up proper audit logging so you can use it later on in your SIEM, in your security event monitoring. Very important, of course, cross-site request forgery tokens. The enforcing of a get or a post method is also very important. So all those type of things we try to give you already at the beginning, saying, please think about it. And the same for XSS, etc. So this gives you, before you start writing code, already the awareness. Then we have also the verification part, the post-development phase. And that's basically when you already, created code and you want the verification. So like I said in the beginning, you have the ASVS. You can use it as a security requirement, but it's also used in the post-development phase here. to do the verification. So for this example, I start the level 3. So that's the really intensive one, the 170 around security controls. And it starts with the architecture and design, all type of categories, authentication requirements, session management, malicious input handling, data encryption at rest, data encryption in transit, error handling and logging, data protection, the communication protocol of the HTTP protocol itself. You can also harden it and create it more secure. So basically, as you can see, a lot of things to consider and take into, well, in your project. And again, if you miss one or two of those security controls, it can have a very big impact on your security and your quality of your product you're building. So the idea is that the developers can, fill in this list. So verify that all application components are identified and are known to be needed. Well, yes, we have this. We have a script that's running on the Travis that will index all those things and output them, so we already always know which version we are going to run. So I say yes. If I want some more information about the background of the security control, you have the hover over information buttons. And if you have an item that is not implemented or not done, you can select no. We also have not applicable, because some of the things are just not applicable. On the moment you save this checklist and you filled in all the security controls, basically it will now correlate all those results again to a knowledge base item that says, hey, verify that all components and library modules are identified. Well, what is the issue with it? Well, you have external dependencies. There can be vulnerabilities in there, so you need to know which version you have, and you have an automated process for this. As you can see, if you really don't do anything with security, it's a huge freaking document. It goes on like this. So it will be hard in the beginning to use this, because probably you only do, well, it's on a best effort based thing. Maybe you only know like 40 or 50 security controls. So the more you use it, the more you're working with it, it will be standard procedure. So you won't fall into the old situation where you have just a normal application. You say, well, we don't do SQL prepared statement and binding here because, yeah, it's low risk. No, it's applicable should be applicable for all the controls. So this is the Security Knowledge Framework. It's all there, free to use. And I will also go a bit in depth later on about the GitHub and the whole continuous integration flow. So, like I said, the whole point, the whole idea is to give you this knowledge, to give you awareness, to share this with everybody, so you can do your work proper. And like you want, because like Martin said, you want to be appreciated. You are the connection between the business and creating this awesome, like world that wasn't be there before, but you guys programmed it. You hooked them together, right? You make things possible. So I'm really a fan also of a real development lifecycle, and basically also, well, continuous integrated. But there are still things you need to do manually. So using the security knowledge framework, getting the information out of it, using the pre-development phase, using the post-development phase, choosing at the beginning of the product a security requirement level, so 1, 2, or 3. So there's still a lot of manual stuff, code reviews, for example. So if you're writing code, you should always say, like, okay, this is a high threat functionality, this is low, this is medium. So in the moment some colleague changes like a login or a password reset or really highly critical impacting functionality that really can have big impact when it's done faulty, there should be code review. So you can say for all the high type of dangerous functionality, there should always be a code review by 2 guys, not 1, not 2, because you want to have this quality of the security. The same for the SAST and the DOST. It's really nice that you can run a static application security scanner, but it takes a while to to be finished, and then you get this yay big of security findings. Then you have to go through them all to validate if it's really a finding or not. So it's still manual work. You can kick it off, automate it, and the same for Dust. Somebody has to look and check and follow up all the findings. Luckily, there are also things that you can automate away. And I really love this because, like I said, security is one of the quality aspects, but also, well, that your usability of your application, of course. I mean, that's what the whole customer wants. If it's usable, if the functionality are working. So how can you catch this into a process? So for the Security Knowledge Framework, we also built a whole development lifecycle. We use Travis, Coveralls, and Scrutinizer. All those services can be hooked from the GitHub. I will show you in a bit. And if you have your own open source projects, you are allowed to use these continuous integration servers for free. So that's really awesome. I will now show on the GitHub how it would look like. Oh, let me. And basically, so like I said before, every hour the new code from the GitHub is pushed to the demo, gone through all the steps to see if everything is working as expected. And like I said before, the Security Knowledge Framework uses Travis. So Travis is basically sort of a build platform, a test platform. Make it a bit bigger. And basically what you can do, you have a .travels.yaml in your GitHub. There you can define which type of language, which versions of this language you want to test, the dependencies, the requirements, and basically you can also, when it's all correctly and there is no exit code, you can also kick off the unit testing, as I do here. So how would that look like? So in here I have a pull request. Somebody updated the requirement, and on the moment I push this request, this pull request, there's multiple things going on. So first it will go to Travis, and it will run here the new commit and tries to build the project again. So as you can see here, it pulls a new one, it installs all the necessary dependencies, and then it will test, build, install on the Travis machine on a new box, Unix box, to see if it still properly compiles, it works, there are no syntax errors, all that type of stuff. On the moment that's finished, then the second quality gate is kicked off. That's basically the coveralls, the unit testing. So when that is done, the Travis, it will kick off here the unit testing. And if that all pass, then it will update these results to the coveralls. And you can see here in one look, you can already see, okay, so the coverage is the same, it's green, it was all good, perfect. I don't have to review or do anything about it. It's the same. So you have this quality gate in here. And the last one is basically where you have the code quality. So this is not a security code scanner or something. No, this is code quality. Because it will look at dead-end code. It will look at complex code. It will look at duplication of code. There are all signals of low quality when you, as a developer, copy code or do stuff like that. So for example, on the Security Knowledge Framework project, I have like 2 Ds on the project checklist and the download file checklist. Well, you probably can already know why, because I copied a lot of code from the one method to the other, and it's a very big, complex function. So yeah, this tool already gives me like a pointer, hey, this is not efficient code. You should rewrite this, because your duplication, it's hard. So it's all about quality again. So on the moment somebody pushes this request, and I can see in one eye what happened, what the build percentage was, the unit coverage test was, and basically I can now easily, with less effort, accept pull request or accept pull request. So in the beginning, we didn't have this. So it was really hard for us because every time we had to do this manually. And we thought like, yeah. And sometimes we missed some of the testing functionality, so it was really hard. So I would say with all this information, with all this knowledge about a development lifecycle, where you can indeed hook also, for example, a ZAP tool or a static code analyzer. You can do that, but still you have to put some manual effort in. But there are tooling out there that can help you, like the Travis for the building, the coveralls, unit testing. It's important to have something set up like that. If you have a slow release cycle and you cannot release very quick, then you could have a big issue when you have a serious security issue. Because if you cannot release or test that fast, then yeah, you are having a big risk there. You're vulnerable till the moment you can do the new release. So having this set up makes you very flexible and also in a security way, like dealing with security issues, that you can patch quickly, go through the whole street, and then if all the checks are green, thumbs up, you know it's good, you can release it to the next box. So the whole idea is that you have now the skills, like Neo in the end of the movie, where he doesn't have to, he knows, right? He doesn't have to see, he already knows. And, you know, don't stop bullets, like by dodging them, but like, be Neo, stop them, right? I mean, so we would really appreciate more involvement from security guys, from coders, from other people who say like, I need this, or I would love to see this type of features in this framework. Of course, we give everybody credit. We give also cool hoodies away if you help. So please. And of course, that's something I really want to stress out. Please help also each other. I mean, you are only so strong as the weakest in your team. And if you see somebody struggling, help him. Try to teach and preach. That's the only thing that we really can do, help each other. Yeah, and then basically the last thing, the questions. Anybody has a question?
Hi. Did you think about maybe doing something like this quality tests, so implementing in this framework, security knowledge framework, some tests that it checks the code for if the all the features that are needed are implemented. For example, like in HTML, as you show us, the specific functions or maybe I don't know sample of codes are there.
Well, the idea we had for also continuous integration is that you could add the name of the category to the functionality you're writing. So if you do, I don't know, something with input like SQL or HTML, then you could define the category from the ASVS, I don't know from the top of my head, but say like the 2.0 security controls, then you could say, okay, so you're doing something with user input, show the developer the list of that category with like a couple of security controls and ask him, did you thought about it? So then he can just say yes or no, right? Without, because what I really notice is that the SOST and the DOS tooling, they have no context. It's really hard. Sometimes you have built your own code to give them context. You have to do a lot of stuff to get somewhere. And I trust more you guys, the developers. You have the context. You created the whole beautiful application. So if I can teach you the hacker mindset and create the awareness what all the possibilities are on the attack vector level, and give a guidance how to tackle this, well then, you know, the SOS and DOS and all that type of stuff is really nice because it's only a safety net, right? It's just for a Monday morning or Friday evening, you know, like when you're went out or something. So it's a different approach, and I used it already a lot at the company I work and other companies. And in the beginning, I had to sit there, help them, go through them, explain it. But now they are doing this on their own. So I'm not even there. Sometimes they come and they need some guidance, so I give it. But the framework really helps them and decide where is the risk, if they implement it correctly or not. And what I also do personally, I go one step further. So you do the security requirements, you do pre-development phase, you do the post-development phase, where they verify all the security controls, and then when they implemented everything, I go to the developers, do a sort of like extreme programming, sit all together in a room with the code on the beamer, me looking at the security control, saying, okay guys, security control 1, verify yada yada, show me. And then we really dive on an implementation level, and I challenge them to really see if they understand it and implement it in a correct way. So you do this a couple of times, this iteration, and then, well, they become Neo, right? So, any other questions?
Hi, Glenn. I really like that security knowledge framework. I got a question about those controls and what framework were those controls selected. Also, you mentioned the level of controls, 1, 2, and 3, and you alluded to banking would be level 3. Is there guidance about what type of data would be for a level 1? And also, I'm interested in the number of controls for each level. How much difference is there between level 1 and 3?
That's a good question. So, like I said, the application security verification standard, that is another project already from OWASP, because like a year ago when we started this project, we had our own checklist in that. Then I found Jim Manico, and he said, no, we have the ultimate checklist, and you should use this in the post-development phase. So then we implemented it. And basically, the thing is, the ASVS is a PDF, and it gives you the guidance also, can we go there? Yes. How to use this standard. So it will give you, if I'm correctly, it's in the document, it will give you like, okay, so healthcare business, banking, or that type of stuff should always do the level 3. Like a football, soccer club with just static content on it, you could do a level 1 or level 2. And I must say, the difference is that, for example, the level 1 is more like top 10 and more. So that's the main focus, because everybody knows the top 10 security issues. The level 2 is a little bit more advanced, and the level 3 is really paranoid. So it's like wiping your sensitive data from the memory after you're done, checking on every TLS connection that it has enough entropy, or the tokens that you generate are secure enough, and you build those checks inside your application. So the level 3 makes your application defensible application by design, by using the input rejection, the audit logging, the validation, all the secure patterns. So it's really in depth. In here you have, this is what I was looking for. So you have the recommendation. So the finance and insurance should, you see it, the recommendation, what they should do or not do. So this document is really good to, even get more context about which security requirement you want to use and which one is, applicable for your project. So I would definitely have a look at the OWASP ASVS project, look at the PDF, and, we made it a sort of a dynamic version, an expert system inside the Security Knowledge Framework. So, Jeff, I hope that was